So now we're going to look at the electrical panel board diagram. And a panel board diagram looks and works just like a schedule, except it's also sort of a diagram of the breaker box, the panel board. So you have these numbers, the odd numbers on the left side, the even numbers on the right side, that represent the breaker switches, the circuits. And then you work straight in. It's a straight line from the number into the center on these diagrams. So from the number, you get to the load. How much load is actually going on that particular phase of the system? And this happens to be a three-phase system. We're not going to get into the differences between a single-phase system and a three-phase system. Just know this is a three-phase system, and that's why you have this step-down look to your panel diagram. Because what they wanted to do is they wanted to make sure that the load was underneath the correct phase, A, B, or C, so they could sum the loads in one column for each individual phase. But you still follow this straight across. So you go from the breaker number to the load to the size of the conduit pipe to carry the wire. Then you get to the size of the wire itself. Most of the wire on this panel board is 12 gauge, but when you get to circuit 22, then you find out it goes up to 10 gauge. 10 gauge being larger than 12 gauge. Then the next thing that you see going in are the number of amps that it takes to trip the breaker. So once you pull more than those number of amps through that circuit, the breaker trips, it turns off. And that's to prevent overloading the circuit, causing too much heat in the wire, possible fire, things like that. We see that all these circuits are 20 amp, so you can pull up to 20 amp through these circuits before the breaker would trip. And then the last thing, the thing in the center, is to indicate which phase that circuit is on. And what you'll see is a pattern. It goes ABC, ABC, ABC. And that's the way a panel works. Each breaker on the panel, when you go one level down, you move to a different phase, and then it repeats. And at the bottom of the panel, you have summary information. For instance, how to mount the panel, or the total loads, different parts of the system. That's pretty much it for the panel. And here's a picture with the panel cover off. You can see the three phases coming in, the three hot wires, the black, the red, and the blue. You can see the neutral wire coming down the side. And on the left-hand panel, you can see the breaker switches already snapped into place. On the right-hand panel, you can see that nothing's been wired and no breakers have been snapped into place. And then finally on electrical, we want to show you the diagram that takes the power from the utility company and distributes it to the panels in the building. And you can see that here. It starts with the transformer box and it comes in, it goes through the building, indicated by this line. And when it gets in the building, it goes to a master distribution panel, a panel that distributes the power to other panels. Some of these panels have cutoff switches, some of them don't. And then you have this one interesting thing coming off the very first circuit, going to a box which says MTS by it, and then going to panels A and B. So what do you suppose that is? It's a backup generator. And the MTS is a manual transfer switch. So the power comes from the distribution down to the manual transfer switch and then to panels A and B. So when the manual transfer switch is in one position, it's taking power from the distribution panel, which takes it from the power company and brings it into panels A and B. When you flip over that manual transfer switch, there is no longer a connection to the main power source, but there's a connection to the backup generator. Now the generator is supplying panels A and B, but nothing in that point would be supplying power to the other panels. So in the case of the utility company being down and not supplying power, the generators will back up panels A and B, but nothing will back up the other panels, and those will not have power at all. And the last thing we want to talk about in electrical is grounding this entire system. Electricity can be very dangerous, right? Anything touches metal, it conducts electricity, so we want to make sure that if electricity ever does touch something metal, that is grounded and it will trip the system. And that's what a grounding system does. So you can see here a diagram of a panel. And then they have a wire that leads to grounding rods. Those grounding rods are long and deep. They're put into the soil. And then they're connected to one another. And then they're also bounded to anything metal, like a metal building, so that if electricity hits that metal building, electricity will be taken to ground, trip a breaker, and therefore when you touch the metal, it won't electrocute you.